Hey folks, today we're going to take a look at friction hitches for technical rope rescue. Friction hitches allow us to attach one line to another to grab that line when loaded and ideally slide the hitch around when unloaded. This serves all kinds of purposes like progress capture on a haul or even a standalone belay on some main belay systems. There are a ton of different friction hitches out there, but I'm going to focus on the ones that we most commonly see in technical rescue, which are the 3-wrap Prusik and the Valdotain Tresse, or VT Prusik, and its variations. Let's start by talking about the 3-wrap Prusik. This hitch has been around for a very long time, and there is an enormous body of research logged on its performance on different combinations of materials. A common misconception is that there needs to be a certain difference in rope diameters for a Prusik to grab on, and this is not true. If you don't believe me, go tie yourself a single strand purcell Prusik and you'll see the line can grab onto itself with no difference in rope diameter whatsoever. What does matter is that the Prusik material is supple enough to wrap smoothly around the line you're attaching it to. If you bend the material between your fingers and it leaves a big gap, like more than half of its own diameter, it won't grab reliably. That's why stiff, older Prussiks that are a little glazed and dirty from use don't grab as reliably as soft, new materials. Continuing with respect to materials, we know that as long as it is supple, we can use a wide range of cordage diameters to make a Prusik loop. So, what diameter should we use? Back in 1991, John Dill rocked the rescue world by asking a simple question. Are you really on belay? His 2-part article answering that question found that you can't just slap any device on a rope and expect it to catch a worst-case rescue load. He examined Prussiks in particular detail and found that 2 8mm nylon Prussiks attached in tandem on 11mm rescue rope provided the most security as a belay. These Prussiks could lock up when subjected to a worst-case fall, so he suggested attaching those Prussiks to the anchor with a load-releasable hitch in order to solve that problem. This configuration, the tandem Prussik belay, became a pretty standard practice for a very long time. As modern ropes got skinnier and skinnier, we started seeing 7mm and even 6mm Prussiks in use. We've already established that with supple cord, there is no needed difference in diameter between rope size and Prusik size, so why use skinnier cord for Prusiks? The answer is some combination of weight, bulk, cost, and misconceptions about sizing ratio. That said, nowadays most teams are using either 9/5, 10, or 11mm ropes, so what size Prusiks should we be using? Well, that depends a lot on where you're going to put the Prusik and what you expect it to do. I'll go down that rabbit hole in another video. Generally speaking though, we use Prusiks in 2 places. One, as a rope grab for the haul or tractor pulley, the pulleys that move in a mechanical advantage system, or as a progress capture or auto stop to hold loaded lines if the operators fail to do so for whatever reason. In single main single belay systems, we may also see tandem Prusik belays or VT Prusiks used as a standalone belay, which I'll talk more about in another video. For our purposes though, Prusiks used in that manner need to perform very similarly to those used for auto stop on a loaded line. I'll also dive deep into where Prusiks should be used in another video. If you're using Prusiks as a rope grab for the haul or tractor pulley, the size doesn't really matter as long as they grab. If they slip or fail, there is no impact on the rescuers at the other end of the line. They don't matter for life safety in that application. However, if you're using those Prusiks as a progress capture or as auto stop, they must be capable of holding a rescue load. Accordingly, we want them to be strong. It's generally accepted that 6mm Prusiks are not strong enough to be used in that configuration. So if we're using those Prusiks as progress capture or auto stop, they should be 7mm or 8mm in diameter. As I mentioned, there is an enormous body of data on the performance of 7 and 8mm Prusiks on 11 to 13mm nylon and polyester rescue rope. If you're using a different combination of materials, for example, 6mm Prusiks on 9.5mm rope, you really need to perform a series of drop tests with load cells to determine just how that combination will behave in a worst-case scenario. We'll talk about that more in another video as well. What about tied versus sewn Prusik loops? One of the nice things about a 7 or 8mm nylon Prusik is that you can simply tie them up as needed from an inexpensive spool of cordage. However, in the professional rescue world, tied Prusiks are falling out of favor. Maybe this is just a money grab on the part of rope rescue equipment manufacturers, but I do think that sewn nylon prusiks offer some advantages. Tested, quality-controlled fixed loops of a given size for a given color with less bulk and less room for operator error make our systems just a bit safer, so I would err on the side of using pre-sewn commercial prusiks from a reputable manufacturer for rope rescue rather than tied Prusik loops like most recreational climbers use. On that note, what about the Sterling hollow block? This darling of AMGA guides has permeated the recreational climbing world, but the testing I've seen in rope rescue systems does not support the use of the Sterling hollow block for technical rope rescue. So if you're seeking the most versatility in prusiks, you'll want to equip yourself with some supple 7 or 8 mil nylon pre-sewn Prusik loops for 3-wrap prusiks. To summarize, for the 3-wrap Prusik with a sewn nylon loop, the pros are they're inexpensive. They are pretty much universally known among rope rescue practitioners, and they're easy to visually safety check. They grab in both directions, and there is a vast body of research on performance of different combinations of materials. Furthermore, they mind well on Prusik minding pulleys. Go figure. The cons are that not every combination of materials has been tested adequately. They can become stiff and less grabby, requiring operator attention. Nylon has a relatively low melting point compared to other newer materials, and they can be damaged in a worst-case scenario. If subjected to a large enough force, they can lock up on the rope and require a load-release hitch to remove. And generally, 3-wrap nylon prusiks cannot be moved while under load. So now let's talk about the VT Prusik. In the last few years, a friction hitch known as the Valdotain Tresse made its way from the arborist community into technical rope rescue. This slick hitch and its variations have some major advantages over a traditional 3-wrap Prusik, but some drawbacks as well. But first, let's make sure we're speaking the same language. To tie a Valdotain Tresse, you need an open-ended Prusik cord. That is, a length of cordage with small fixed loops at either end, rather than one continuous loop of cord. You can improvise this by tying loops in the ends of a piece of nylon cord, but that is a very bad idea. See, the major advantage of the VT and its variations are that they can be released under load, and a skilled operator can slide it over a loaded line, very much like a belay device. Sliding loaded nylon on loaded nylon causes friction and heat, which will damage a nylon Prusik cord. So if you're going to tie a Valdotain Tresse or variation, you need to use a specially built device. Blue Water Ropes makes a device they call the VT Prusik. This is a 33-inch length of cord with heat-resistant Technora sheath and a nylon core with sewn loops on either end. The Technora sheath allows for sliding loaded ropes over the cord with less concern about melting and glazing. It comes in 7 mil and 8 mil diameters. You can use a Blue Water VT Prusik to tie a Valdotain Tresse, or a Max Over 1, or even a regular old 3-wrap Prusik. Not confusing at all, right? For our purposes, though, anytime I'm tying a Valdotain Tresse or variation thereof, I'm going to show that using the Blue Water VT Prusik cord. It is not a good idea to improvise a VT Prusik cord out of nylon. Valdotain Tresse looks like this. The major advantage is that it can be easily released under load and even feathered to allow an operator to lower a load on it. However, it takes some skill to tie this correctly, and a small error could result in the load going to the ground. Furthermore, it hasn't been tested nearly as extensively in rope rescue systems as has the 3-wrap Prusik. And there are easier and more intuitive variations that offer similar performance, which leads us to the Schwabisch hitch. This is also known as a Max Over 1 hitch and is simply an asymmetric Prusik with the maximum number of wraps on one side and a single wrap on the other. Instead of putting 3 wraps on both sides, you'll simply put 6 or 7 wraps around one side and 1 on the other. This works very much like a Valdotain Tresse in that it can be released under load, but it's easier to tie and inspect. It's a little bit more intuitive. The hitch can theoretically be released under load, but I have seen reputable testing that suggests that under a worst-case rescue load, it may be impossible to release a Max Over 1 on a loaded line. So, depending on where you use a Max Over 1, you may want to attach it to the anchor using a load-releasable hitch. The max over 1 is a single direction hitch, and if you attach it upside down, it will not hold a load at all. The load will go to the ground. It also may not mind well on pulleys, and so many teams use the distal hitch variation, where the bottom wrap goes in the other direction, so they're coming out either side, and this tends to mind better on pulleys. Again, these variations all require the specific Blue Water VT Prusik device to tie safely, and if you're going to use a combination of materials that hasn't already been tested extensively to confirm compatibility, I would advise doing some drop tests to make sure you really are on belay. As an aside, regardless of the type of hitch, friction hitches on 2 strands are a no-go in technical rope rescue. Their behavior is less predictable than on single strands, and if one rope were to fail, the hitch may not re-grip reliably. So it's a big rabbit hole, but suffice it to say that for technical rope rescue, we shouldn't be putting prusiks around 2 loaded lines at the same time. So there you have it, a moderately deep dive into the 3-wrap Prusik, the Valdotain Tresse, and its common variations used in technical rope rescue. As promised, I will talk more about the strength of these various Prusiks, as well as where to best use them in another video. So drop any questions, comments, or discussion in the comment section below, and I'll put citations and additional reading in the description. Thanks for watching.